Hello everybody and welcome back to another exciting edition of Ed Puzzle Notes. We are now entering the exciting world of Ecology 2, the second part. There will be an Ecology 3 and yes, an Ecology number 4. This right here is a food chain. I think we're kind of familiar with this. A food chain is a linear series of steps which shows how energy gets transferred from one organism to the next. And once again, here is that same food chain. So, energy always originates in that thing in the sky, which we call the sun. It sends its energy to plants, the producers. So this is the producer or autotroph. And then the energy goes up through the food chain. The first guy that's going to get it is this guy right here. It looks like a grasshopper. It's a locust. He's called the primary consumer. If you eat plants, if you eat producers or autotrophs, you're a primary consumer. And you can signify that with the number 1 with a little degree sign. Next, it's going to move on. When the locust gets eaten by the lizard, that transfers the energy into the lizard. And now you can call he's a secondary consumer. And you can put that by putting a number 2, a little degree sign. Shows he's a secondary consumer because he's the second one to get the energy that started off in the corn. And then the last stage here of the food chain, it goes on to Mr. Milk Snake here, just like Jake that's in the classroom. He is now the tertiary or the third consumer, tertiary. So he'd have a 3 with a little degree sign. So you have your primary consumer, secondary consumer, and tertiary consumer. And things do eat snakes. If, like, say, a hawk or something ate that snake, he would be the quaternary consumer, the 4 with a degree sign. All right, now this is something a little bit different than a food chain. Food chains are kind of good, but birds don't always just eat grains like here, or they don't just eat grasshoppers. Birds eat a lot of different things. So when you put a bunch of food chains together, you make what's called a food web. And that's what we have here. It shows all the feeding relationships that you find in an ecosystem. So for here, you can see here's your producers, the grains and the grasses. So Mr. Grasshopper here, he would of course be what type of consumer? Since he's eating the producers, he's a primary consumer. Mr. Bird here also eats the grain, which makes him a primary consumer, but you can also see that Mr. Bird eats grasshoppers also. So the bird would also be a secondary consumer. Now let's look at Mr. Fox over here. Mr. Fox, rabbits eat grass, makes the rabbit a primary consumer, and then the rabbit gets eaten by the fox, which would make the fox a secondary consumer. But if you look at this route, the grass gets eaten by the grasshopper, which gets eaten by the bird. So the grasshopper is primary, the bird is secondary, and then the bird gets eaten by the fox. So when you go that route, the fox would actually be a tertiary consumer. All right, here's another food web. Once again, these are food webs. Remember, energy always starts in the sun, and that energy gets transferred to the autotrophs. That's where the food chains start. They start at the bottom with the autotrophs, mostly plants. All right, I'm going to ask you a couple questions about this food web. And here's a little picture of like a forest ecosystem. Obviously not realistic. You're not going to see this many animals that close together. If you actually go to the forest, you'd be but kind of think about it. If you go to the forest, what are the chances that you'll see plants? Like a tree or grass, flowers. What are the chances? I'd say if you're in a forest, the chances are basically about 100%. You're going to see a tree or grass. You're going to see plants every single time. Now, how about the herbivores, the primary consumers, the things that eat plants, like say maybe this squirrel over here. or maybe these rabbits, or the birds. What are the chances that you'll see one of those? Those are very, very common. You see them pretty much all the time. So, I mean, at least 85% of the time, you'll see animals like that. Now you move it up the food chain. Larger animals, like say a deer back here, or this elk right here. How often do you see those when you go to the forest? Much rarer. They are larger animals higher up in the food chain. So maybe, I don't know, 10% of the time at most. Now how about when you get to the very top of the food chain? Like Mr. Bear here. I've been to the forest every year for my whole life. I've seen a bear one time. One time in my life have I seen a bear out in the forest. That's because the bear is at the top of the food chain. As you move up and up and up in the food chain or food web, the numbers of those organisms goes down. So you're going to see millions and millions and millions of plants. You might see in an ecosystem, there might be maybe thousands of squirrels. There might be hundreds of rabbits. But there's probably only going to be one or two bears. There's probably only going to be maybe 6 or 7 wolves. Maybe 9 or 10 deer, whatever. So as you go up the food chain, the numbers of those organisms goes down. Now this slide kind of goes with the last one. This is a term, it's called biomass. Biomass. Well, if you break it down, bio always means life, and mass kind of means weight. And so what is biomass? It's kind of like life weight, but what is it? It's the total amount of living tissue in a trophic level. That makes up biomass. So you can see here, there's all this corn. If you put it on a giant scale and weighed it, you found out how much mass it is. That would be the biomass in that cornfield. And same thing here. Plants, animals, the total amount of living tissue in a trophic level or in an ecosystem, that's what makes up biomass. And kind of like with that last picture I wanted you to see, as you move up in the food chain or food web, the amount of biomass goes down. And that's why we use this shape right here. It's called an ecological pyramid. If you've seen a pyramid, the bottom is always the biggest. And bottom, that's where the plants are at. Plants, the producers, have the highest biomass. If you weighed all the plants, it would weigh more than all the other trophic levels. The next one up are the primary consumers. Those are the herbivores. In this case, they're grasshoppers. They would have the second amount of biomass. Even though little crickets or grasshoppers, they're small, there's a bunch of them, and they're all feeding on the grass. And now we move up to the secondary consumers. There's fewer of these, because it takes a lot of these little grasshoppers to feed one bird. So that means there's got to be fewer birds. And at the very top, there's only one hawk, because it takes a lot of these littler birds to feed that one hawk. So as you move up the food chain, biomass goes down. And here are 3 more ecological pyramids. They're all pyramids, it's always that same shape. This one shows the amount of available energy. Now, this is going to be kind of important. You can see down here the producers, they have 100% of the available energy. Now, the things that eat the producers, the primary consumers, they only get 10% of that original 100%. And this is called the 10% law. As energy gets passed from one trophic level to the next, only about 10% of that energy actually gets passed. The rest of it gets lost as heat. So as an organism is doing its daily metabolism to stay alive, a lot of that energy produces heat, and that heat just escapes back into the air. That heat cannot be passed to the next trophic level. It is lost. So that's the 10% law. Every step up the food chain, only 10% of the energy actually gets passed. The rest of it was burned in the animal's metabolism. Now this one right here is just like the last one. As you go up, biomass goes down in an ecosystem. So here it shows it takes 1,500 grams of grain to support 500 grams of a chicken, and it takes 500 grams of chicken to support only 50 grams of human tissue. So what does that say? It takes a lot of chicken to keep this person alive. And the last one shows the relative numbers. And that was just like I said last time. If you're looking for plants, it's not hard to find plants because they're everywhere. There's tons of them. Now, if you're looking for the things that eat plants, the primary consumers, they're pretty easy to find too because there's a lot of them, but not as easy as if you were looking for plants. Now the secondary consumers, the snakes here, much rarer. There's not as many of these guys as there are the trophic levels below. And the rarest of all are those predators at the top of the food chain. They're the rarest of all because the numbers go down as you move up the food chain or food web. All right, last slide and the last term of today. And once again, we're going to break this word down. Bio means life, and magnification kind of means to make larger. So biomagnification. And what this is, in especially aquatic ecosystems like the ocean, there's little things, there's like little toxins that's in the ocean. And we're going to say it's mercury. Toxin mercury, it's a metal, it can get in your body, and it's a toxin. It can kill you if you had too much of it in you. Well, anyways, these little guys at the bottom of the food chain, like say algae or plankton, they get a little bit of that mercury inside of them, just a tiny little bit. Not really much to even hardly measure it. Well, the next thing up is this mayfly. It eats tons and tons of this algae. Tons of this algae. And every time they eat them, they get a little tiny bit of that mercury. So the mayfly nymph, it has a little bit more mercury than the algae did. Well, the next time we go up, it's the sunfish. And this sunfish eats hundreds and hundreds of these mayflies. So the mercury in their bodies is becoming even more concentrated as it eats a bunch of those mayflies. And the last guy on the list is the great blue heron. It eats a bunch of sunfish. So the toxin in its tissue becomes even more magnified. And that's why organisms that are on top of the food chain suffer the most from what's called biomagnification, because as you move up, the amount of that toxin in their tissues gets higher and higher and higher. All right, thank you very much for listening, and I'll talk to you next time.